Okay, so we've discussed that atoms consist of a nucleus containing neutrons and protons, and then the electrons are in shells around that nucleus. So here's a little diagram of an atom, and you can see it has a nucleus at the center, not the scale, that contains our neutrons. So this has 6 protons and 6 neutrons. The number of neutrons and protons doesn't always have to be the same. It tends to be the same at the lower end of the periodic table, but the heavier elements tend to have more neutrons than protons, so don't always think those two numbers are the same. And then we have 6 electrons in orbit around the nucleus. Now, the number of electrons and the number of protons does have to be the same, okay, for atoms, because the protons provide a positive charge of +6. The electrons will provide a negative charge, and those two things have to cancel out. So because each proton has a charge of +1, each electron has a charge of -1, for them to cancel out, the number of electrons and the number of protons have to be the same. Now, rather than trying to draw diagrams like this to represent our atoms, we'd like to do it in a more shortened form, and we kind of represent this by symbols. Okay, so each type of atom or element has its own symbol. So for instance, this atom here is an atom of carbon. So we use a capital letter C to represent it. And we then provide two numbers with that. The bottom number here is really the most important one, okay? It's either called the proton number, but more often it's called the atomic number. And what it tells us is the number of protons, okay? So you can see here it's 6, and that tells us that it has 6 protons. But in reality then, that's also telling us that it has 6 electrons, okay? Sometimes it's called the Z number because we use the letter Z to represent it. The top number up here, the 12, is sometimes referred to as the nucleon number, but in chemistry and more commonly, it's referred to as the mass number, okay? Because it's the number of particles that have a lot of mass really in there. So in this case, we have 6 protons and 6 neutrons. The electrons are so light, they don't really contribute to that. So this mass number is effectively the total number of neutrons and protons. So we have 6 protons and 6 neutrons, which means this should be 12. Okay. Confusingly, we use the letter A to represent this, while the atomic number is the letter Z, so don't get those two mixed up. Okay, let's look at a couple of examples of this then. So here we have the chemical symbol for lithium. You can see, in fact, we don't use one letter for this, we use 2 letters. If we use 2 letters, the second or even third letter, if it comes to it, are lowercase. So this is lithium. The atomic number here is 3, and remember, that tells us the number of protons. So we know it has 3 protons. The number of electrons is always the same. So an atom of lithium will also have 3 electrons. Meanwhile, the top number is the mass number, the bigger number, and it tells us the total number of neutrons and protons together. Okay, so the bottom number is the number of protons, top number is the number of neutrons and protons added together. Therefore, to get the number of neutrons, we know there's 7 neutrons and protons together. 3 of them are protons, therefore 4 must be neutrons. So to find the number of neutrons, we take the top number and subtract the bottom number. Okay, therefore we can tell that lithium would have 3 protons and 4 neutrons in the nucleus, and then it would have 3 electrons in shells around it. Remember, you will not have to, I know you might do this in chemistry, I think you did it in year 10, you will not have to do electronic structures in physics. Let's look at an atom then, if we have to do the reverse of that. So we're told that this is 12 protons in the nucleus, 13 neutrons, and then 12 electrons. You can see that makes sense because the number of protons and electrons are the same. Therefore, the atomic number of this element will be 12. Okay, the bottom number, because that's just the number of protons. To find the mass number or nucleon number, we add the two together because the mass number is the total number of neutrons and protons, and that gives us 25. Now everything that has an atomic number of 12 is magnesium. Okay, so this is actually an atom of magnesium. What you need to do now is try the questions just below in this booklet, and then I'll post a little video with the answers below that.